Alright, in this video we're going to go over optimizations. Alright, so this is yet another use for the derivative of a function. Alright, so here's a problem. It says Dr. Hammond has a pet T-Rex that he wishes to keep enclosed in an electric fence in the shape of a rectangle. He has exactly 240 feet of electric fence available. What dimensions should the electric fence pin be to give a maximum amount of T-Rex goat eating grazing area? Alright, so first we need to start off by defining the problem. What's our problem? Well, we want to find the max area. Alright, we want the maximum amount of area. An area of a rectangle. We know that the area of a rectangle is length times width. Alright, this being the length and this being the width. Alright, now what you need to do is we need to define your constraint. Define your constraint. What's our constraint in this problem? Well, we only have 240 feet of fencing. All right, so that is our constraint. We only have 240 feet of fencing. Okay. Now, we also have to look at what we're trying to achieve. Well, we have 240 feet of fencing, so that means that our perimeter, that means we have to look at perimeter. All right. So we are going to figure this out using some of area, but we also have to keep in mind the perimeter as well. We have to make sure we have exactly 240 feet of perimeter. Okay. So now we need to define the constraint formula / equation. All right, so in this case it's perimeter. Well, perimeter is 2L plus 2W. All right, 2L plus 2W. We know that perimeter is going to be 240 feet. That's going to equal 2L plus 2W. Well, if we divide everything by 2, we get 120 equals L plus W. That is going to be important. We'll figure this out here pretty shortly. All right, so 120 equals L plus W. Now, I'm going to move over here a little bit so I have more room to write. It says, use the constraint to simplify the main problem. What does that mean? Use the constraint to simplify the main problem. Well, that simply means get rid of one letter. All right, because we don't want multiple letters, because you can't solve a single equation if you have multiple variables. So we want to try to get rid of a variable. Well, how are we going to do that? Well, 120 equals L plus W. Let's solve it for L. So okay, so minus W, minus W. So 120 minus W equals L. All right, 120 minus W equals L. Okay, now going back to the area equals length times width formula, we can now plug in 120 minus W for L, therefore eliminating L in our equation for area. So area now equals 120 minus W times W. And if you simplify that out, multiply it through, it's 120W minus W squared. All right. So now we have simplified our main problem. We want the maximum area. Well, this will help us. This is going to help us get our maximum area. Area now is 120W minus W squared. Okay. So now what we want to do is we want to find. I know there's a lot of steps in this. You just got to remember them all. Find maxes slash mins or mins slash maxes. So how do we do that? Well, we want to get a prime. All right, a prime is, of course, you take the derivative of a. Derivative of 120w is 120 minus w squared, which is 2w. All right. Now, so that is our derivative. Now, to find our maxes and mins, what do? Well, we set it equal to 0. All right. So now to solve, and we're going to solve for w. So minus 120 minus 120. Negative 2w equals negative 120. Divide both sides by a negative 2, right? And w equals 20. I'm sorry, 60. Why I wrote 20. All right, and that is, of course, in feet. Now, what does that w give us? Well, if you remember back from up here, I'm going to bring this down. If you remember back from up here, 120 equaled L plus W. Well, now we know what W is for this equation. W is 60, so take the 60 and plug it into this equation. L plus 60. Now we can solve for L. Minus 60, minus 60. L equals 60. All right, so L is 60 and W is 60. So that means that our biggest playground is going to be 60. Is going to be a 60-foot by 60-foot square. All right. So that means our biggest playground is going to be a 60 by 60 foot square. All right. Now, some of y'all are probably like, can we do that one more time? Yes. Let's start back from the beginning and go over this again. All right. So define your problem. Well, we want to find the maximum area with 240 feet of fencing. Well, that 240 feet of fencing is our constraint. Now, that 240 feet of fencing represents the perimeter. So that's why now we define the constraint formula or equation, which is the perimeter equation, which perimeter is 2L plus 2W. Well, that 2L plus 2W equals 240. Divide by 2, because everything's divisible by 2. 120 equals L plus W. All right. Now, we took that equation and went over here. Now, you use that equation and you simplify the main problem. Remember, the main problem here is maximum area. So we're going to simplify this equation using our perimeter equation that we just found, because that's our constraint. So what we do? We got rid of one of the letters. We solved this. We solved the 120 equals L plus W. We solved it for L. That way, we could substitute it into our area equation and get rid of a variable. When we substituted it in, we got 120 minus W times W. So our area, you could say in terms of our constraint equation, our area equals 120W minus W squared. All right. So now we wanted to find the max and the mins, and of course to find the maximum and minimum of an equation, you take the derivative. So we found a prime, which is 120 minus 2w, set that equal to 0, and solved for w. Well, when we solved for w, we found the maximum width that the playground can be to have the maximum amount of area. Okay? So now we brought this equation down from up top, our 120 equals L plus W. Now we know what W is. So now that we know what one variable is, we can easily solve for the other one. So we substituted in the W, get 120 equals L plus 60, subtracted 60. So our maximum length now is 60, which means our biggest playground is going to be a 60 by 60 foot square. Okay? And if you just want to confirm that 60 times 4 is 240 feet, therefore meeting our perimeter constraint as well, and it all checks out. All right. Now let's mix the problem up just a bit. Say now we wanted that 240 feet of fencing builds a pen with one side bordering a river. And there's no need for a side there. All right. So this little wonderful blue thing is our river. All right. That's what you get when you search clip art on Google. All right. So now here is our pen. All right. This is still the length here, and this is W still. All right. But now we want to find the maximum area. So again, the problem, to find the problem, it's still max area, which area is length times width. Define your constraint. Our constraint is still 240 foot perimeter. Oops. 240 foot perimeter. All right. And perimeter. Now, perimeter in this case is not going to be 2L plus 2W. Perimeter in this case is going to be 2L plus W. All right. 2L plus W. So that means 240 is going to equal 2L plus W. All right. Now, eliminate a letter. All right, so let's solve this for W because we have 2L, so it'll be easiest to solve this for W. So minus 2L, minus 2L. So 240 minus 2L equals W. All right. Now, we need to plug that in to our um, area equation, just like we did last time. So we know that area equals length times width. Since we've solved this for width, area is going to equal length times 240 minus 2L. Distribute the L through, so area equals 240L minus 2L squared. All right, minus 2L squared. Now again, you need to find a prime. So from here, we're going to find a prime, which is 240 minus 4L, because you drop the 2 down, so 240 minus 4L. And now you solve for L. Okay, so set it equal to 0, plus 4L, plus 4L. So 240 equals 4L, divide by 4, divide by 4. So L equals 60. All right, L equals 60. Now, pulling this equation down, okay, W equals 240 minus 2L. All right, let's plug L into that equation. 240 minus 2 times 60, which is 240 minus 120. So W equals 120 feet. And since our our length was 60 feet, that means that our maximum play area now for our T-Rex dinosaur is going to be a 60 foot by 120 foot rectangle. All right. Now, quick review. Again, we're using the same 240 feet of fencing, but now we're going to let it border a river. So we're going to assume our T-Rex can't swim, or the river is deeper than our T-Rex, because normally T-Rex could just walk through the river and be out of his pen and be happy and free. So we're going to assume that he can't do that. All right. So same thing. You got to define your problem. Well, our problem is maximum area. So area is length times width. Then you got to define your constraint. Our constraint is 240 foot perimeter. It still has to have a 240 foot perimeter. Now define your constraint equation. So our perimeter is 2L plus W. That's our constraint equation, because we don't have a width on this side anymore. So that's why it's not 2W, because we've only got this one width here to worry with. All right. So now, next step, eliminate a variable. All right. So simplify it down. So we solved it for W because W was the easiest to solve for. Because we had 2L, so it had to divide the whole thing by 2, so we would have had W over 2, which we could have done, but we really didn't want to do because we had a fraction, and life's easier without fractions. All right. So after we did that, we came over here, and area is length times width, where we plugged our equation in now that we solved for W into our area equation. Area equals length times width. So area equals L times 240 minus 2L. Distribute it through, so our new area equation is 240L minus 2L squared. So now you got to find the max or min. So we found A prime. We set it equal to 0 and solved for L. We got L is 60. Okay, we got L is 60. Now, just to prove that this is a maximum, what you could have done is found a double prime. All right, when you find a double prime, that gives you -4. Well, since it's a -4, that means that that is a max. Okay, it means it is a max. Because since your second derivative is negative, that means it is concave down, which means our point, our 60 here, has to be a max. All right, so that's our maximum length. So now we went back up here to our equation, 240 minus 2L equals W. We found L, and since this is already solved for W, that's why we used it. All right, so plug in the 60. W equals 240 minus 2 times 60. 240 minus 120. 240 minus 120 is 120. So now our maximum goat eating play area for our T-Rex is a 60 foot by 120 foot rectangle. All right. Now, this is how pretty much all optimizations work. Right? You may have, like if it talks about circles, you're going to have to use circle formulas for perimeter and area. If it talks about triangles, you got to use triangle formulas. But regardless of shape, they're all going to work the same exact way. Define your problem. Define your constraints. Define your constraint equations. Find your, eliminate a variable, find your derivative, find your max or min, plug it back into your constraint equation that you solved for one variable, and boom, you're done. All right. So this has been your video for optimizations. Make sure you understand how to do this. Now, personally, I don't think it's too tough, but make sure you watch this video and make sure you understand how to do this. We will work on some problems going over this, of course, tomorrow in class. Feel free to ask any further questions you have tomorrow in class. See you tomorrow.